If you're still having trouble with concept 17, two things you can do. One, you can look under news and you'll see that there's a sample video on YouTube, a 10-minute quick blurb about how to graph using X and Y intercepts. Two, you can go back and revisit the video from class. Okay, it's not recorded in this class, so it might seem a little different. Maybe that's a good thing for you. Okay, maybe I did a few different problems in the class you should look at. Today I'm going to record 18. We're only going to get through about half of 18 today.
For Amber?
Okay? Amber, yes, for Amber also. You want to say hi? Go ahead.
Hi, Amber. Are you recording?
Yep.
Why'd you look at me like that? You just so
if you would like to, feel free to look at this video tonight. I'm not posting 18 from the other class. I'm posting it from today's class. Okay, tomorrow we'll do the second half of 18, and I'll record that instead of the first 18. Okay, so this is concept 18 we are on already. Remember tomorrow, you need a calculator to do tomorrow's assessment. I'll tell you right now. So even if you don't have one yet, at least borrow one for now. But on the test, you're going to need your own. You can't borrow one there. At least borrow one from another classmate for now. Okay, tomorrow you're going to be finding the roots. We're finding the x-intercepts using the calculator method that we went over yesterday in class. If you're unsure about that, make sure you revisit the video we went over from class. All right. Today we are going to look at direct and indirect or inverse variation. Now, another word for directly related is the two things are proportional. That's another word. Another word for inverse variation is indirect variation. So you can use either of those words for either of those things. If you have a word problem, which I guarantee you will on that SAT, that relates to this kind of a problem, you have to know what those terminologies mean. And we're going to discuss today how to actually figure that out. Now, if I said to you, Melody, and Melody, give me what you think is a reasonable answer for this, okay? The more time you spend studying for your English test, the more time you spend studying for your English test, the blank goes in the blank happens to your grade. What happens to your grade if you spend more time studying? Theoretically, what should happen? It should rise, right? Theoretically, guys, if you spend more time doing work, more time studying, your grade should rise. Now, the more time you, or somebody, not necessarily you, but somebody spends, surfing the web or looking at Facebook posts all day, what happens to your grade then, theoretically? It'll go down because you're spending less time studying. Do we agree with that? Yeah. So, in the first case, as you spend more time studying, so T is time, your grade will go up. Theoretically, again, this is theoretically. It doesn't always work that way. Your grade should go up as you spend more time studying, but it doesn't always work. Now, as your time goes up, your grade should go up. Now, if you spend no time studying, or you never go to school, theoretically, you wouldn't be able to get anything right. So that would be like getting a 0. So what's happening here is we're starting at the origin right here. So if you spend no time in school, and you spend no time outside of class studying, and you simply took a test on something that you knew nothing about, okay, that you knew nothing about whatsoever, then what would happen? You would actually get like a 0 in that sense. So that's the starting point here. And your grade can go all the way up to 100, and however many hours it takes. That is considered to be directly related. Because as one thing goes up, the other thing goes up.
Oh, just like in chemistry.
Very good. I was just going to ask about chemistry. PV over T, right?
Love chemistry.
Remember PV over T equals PV over T?
Very
Very good.
Okay,
Direct or indirect relationship. It's going to be very similar to chemistry. We'll bring up an example of that in a little while. Now, here's how we generally write this. This is an equation of a line, isn't it?
Yeah.
So for a line, our standard form for a line is y equals ax plus b. Now, what is the y-intercept in this case?
It's 0.
It is 0. Very good. The y-intercept is 0 because it goes through the origin here. So there is no b value for direct relationships here. The b value does not exist. So here, what we really have is this. Again, direct variation. The general equation is y equals a times x. Okay, again, where does that come from? It's a line, but that line happens to have a y-intercept of 0. Okay, of 0. Now, another way of writing this is saying a equals y over x. Now, how did I get that? I divided both sides by x. So if I take the right-hand side and divide by x, and divide the left-hand side by x, x's cancel, I'm left with a equals y over x. So I can use either interpretation. Again, this interpretation was written as y equals ax. Okay, so either one of these interpretations work. Either one of those interpretations work. In the blue here, y equals ax, this part right here, or in the green right here, a equals y over x. Either one of those work. I don't have a pointer, so I'm trying to show you guys if you're listening to the video. That's what I'm talking about, green, and that's the blue box down there. So this is direct variation. Thank you. I should have listed that. We already said that. Direct variation. Okay? So the general equation, y equals ax, is an expression that represents direct variation. Y equals ax represents direct variation. Okay? Now, let's start with an example of direct variation, and then what we'll do after that is we'll move on to inverse. So, I'm going to pull up an example that's not in your notes in case you printed them out. Okay, we're going to start with a bit of an easier example first. If you have if the distance traveled is directly related to the time spent traveling. The distance traveled is directly related to the time spent traveling by the equation d equals 5t. Well, by the equation d equals 5t, then how far have you traveled after 3 hours? Okay, how far have you traveled 3 hours? And let's just say also, or in addition, how long will it take you?
Traveling has 2 L's.
I don't know. I'm not sure. Is it 1 or 2?
It's 1.
It is 1, isn't it? I knew that looked funny, and I'm trying to figure that out as I wrote it down. Thank you.
Why don't you just erase it?
That still looks kind of weird, though, to be honest.
Traveling.
What about traveled with ED? That's 2 L's, right?
Traveling, just
No.
either way.
In addition, how long will it take you to travel?
I'm so not gonna let that go. Remember what you did to me in Gospel Rose when you corrected that paper?
I have no
You
idea
made
what
me
you're
feel
talking about.
stupid. You called me out on in front of everybody. Yeah, this is payback.
What are you talking about?
Remember when we were doing we were making up songs for our groups,
Uh-huh.
and then you remember all that you were making that rap, and then I was
I don't know.
I was writing and I misspelled something, and then you called me out on it.
You want us to work that out?
Oh,
We're going to go through it. Give me a second. Right?
I know what you're talking
Yeah, right. Remember he called me out on it, and then everybody was like,
about. And everybody started paying attention to it.
Yeah. Oh, I think it is, or I don't know. I think it is. Yeah. pay back with that.
Glad to hear. Thank you. Again, the distance traveled is directly related to the time spent traveling. By the equation d equals 5t, and how far have you traveled after 3 hours? In addition, how long will it take you to travel 17 miles?
After 3 hours, once you travel,
Tell me, Marcus, 3 hours. What does that represent in words? What is 3 hours a representation of? The what?
time.
The time. The time. So where is that going to go in, guys?
I'm gonna sub that right in.
Okay. So looking at the first part, if I want the distance traveled after 3 hours, d equals 5 times 3. So how far have you traveled after 3 hours?
15 miles.
Good. 15, and we'll use miles here in this case. Very good. Again, the first part says, how far have you traveled after 3 hours? Take the 3, plug it in. Good enough? Second part, how long will it take you? Relax. How long will it take you, like you traveled 17 miles? So what do I know this time? Very good. Now I know the distance. 17 miles is the distance, so that's going to go in up here now. So the second problem, I'm going to have 17 equals 5t. Now, keep in mind, it says how long will it take you, so what am I solving for?
T.
The time t.
Divide, right?
Good. Divide by 5 on both sides. What do you get? Second problem. In addition, how long will it take you to travel 17 miles?
Actually, contrary to what you believe, you actually get 3.4 more numbers.
3.4 hours.
It's just 3.4 straight.
Oh, you're right.
3.4 exactly. 3.4 hours.
No problem.
Now, that is a very, very basic example, just so you know, of direct variation. We're going to do one in a second that's a little more complex than that.
I mean, I get that.
Which part? 3.4? Divide by 5 on both sides. 17 divided by 5 is 3.4. All right, second problem. Please write. I'm going to define a term in a second called constant of proportionality. Another example, second example.
That's not what I'm saying. No.
She going?
So he is there.
You guys make up so many.
What she said? What she said?
You said I can decide it.
Now, that big word there is proportionality. I'll define what constant of proportionality means in a second. Again, I'll define this term in a minute. I'll give you another minute to write it down.
I got to put it
What she said?
That's such a kid.
So y varies directly with x. When x equals 4, the value of y is 24. Find the constant of proportionality, then find the value of x when y equals 18.
Is that 20?
It's a 24. Now, let's start this problem. Look at the first sentence. It says, y varies directly with x. Does not mean they're equal. It means as one goes up, the other one goes up. So what was the equation that we wrote in the very beginning of class today that represented when one thing goes up, the other thing goes up?
Y is AX.
Very good. Y equals AX. That was my equation from the very beginning of class that represented direct variation. Now, the second part says when x equals 4, the value of y is 24. Okay? So let's look for a second. When x equals 4, the value of y is 24. And then it says, find the constant of proportionality. What do you think is the constant of proportionality? I haven't defined it yet.
I don't know.
What is it? It's A. Good. A is what the value is going up by. So what is the slope of the direct variation here? So the constant of proportionality is the A value. Okay, the constant of proportionality is the A value every time. So it says find A. All right, well find A. What do we get? Okay, so what's A? Okay, because we got 24 over 4. Focus, gentlemen. Now, we need to identify some stuff here. This is called the general equation. Whenever you write y equals ax, that is called the general equation, because it generally represents direct variation. Now, look down here. We have a equals 6 now, don't we? So since a equals 6, I can rewrite the general equation as y equals 6x. Again, since a equals 6, we were able to determine the value of a. I can rewrite the general equation that is specific to this problem. And we call this the specific equation. All right? Now, what does the last line of the problem say, guys?
Find the value of x when y is 18.
Okay. Look back at your general equation, everybody. Look up here for a sec.
So X.
If I knew that y was 18, and follow where I'm pointing, please. I'm looking at this equation right here. If y were 18, can I solve for x in this equation?
No.
Because you don't know a, right? But now look down here. If y is 18, can I solve for x now?
Yes, sir.
So we use the scenario that was given, the scenario of 4 and 24. We use the 4 and the 24 scenario to find the constant of proportionality, A. We then plug that in so that we can now find x. Because again, the problem says, find the value of x. Find the value of x when y is 18. If I plug 18 up here for y, I can't find x. It's useless. So I need the specific equation to do this. So in the specific equation, I'm going to have 18 equals 6x. What is x, everybody? 3. Divide by 6. Divide by 6. X equals 3. So let's review this process. Hold it, relax. Several days in a row now, I've got to ask. Let's review this process. First, we have a general equation coming out. That is y equals ax, because it said it was directly related. Next, we are given a scenario. That scenario is the 4 and the 24. From that scenario, we are able to deduce the value of the constant of proportionality. We can figure out the value of a. From the value of a, we now create our specific equation. From the specific equation, we can plug in the 18 for y and solve for the value of x. What do you mean?
24 equals 6. Right? Yes.
24 equals 6 times 3?
No, from the beginning.
The values that you had.
Yeah, the value that
No, it just says, find the value of x. X is 3. You're done.
Okay.
You don't have to do anything beyond that. Okay? Let's look at one that you can actually relate to now. We'll look at if you have a job and you have a paycheck, okay? And see how this works. So let's say we have yeah. Yes, Bridget, go ahead. A person's paycheck, P, varies directly with the number of hours worked. which we'll call W. A person's paycheck, P, varies directly with the number of hours worked, W. What is the person's paycheck after working 17 hours if his paycheck is $96 after 8 hours of work? Okay, and there should be a question mark at the end there. A person's paycheck, defined as P, varies directly with the number of hours worked, defined as W. What is the person's paycheck after working 17 hours if his paycheck is $96 after working 8 hours? So you're given another scenario, 8 hours of work is $96, and you're asked to figure out how many dollars is 17 hours of work. Now, just intuitively, take a look. We know that for 8 hours of work, it's $96. To get from 8 to 17, it's almost double, right?
Yeah.
You're almost working double the hours. So your paycheck should be at least double 96. So if you get an answer that is not at least double 96, it doesn't make sense. Because you're working double the hours, so you should get double the pay. Okay? Now clearly, it's not exactly double, and I did that on purpose. Because if it was 16 hours, you would know just to double the answer. That's easy. But what about 17 hours? What do we do then? So let's take a look. From my first statement, a person's paycheck, P, varies directly with W. That's all I care about. I don't care about all the other words. The paycheck, P, varies directly with W. So immediately write P equals AW. The paycheck varies directly, that's the A, with the amount of hours, W. Yes?
So isn't it in the way like y equals ax?
That's exactly what it is like. Think about y equals ax, except now it's p equals aw. Okay, p takes the place of y, w takes the place of your x. Very good notice there, intuition. Roosevelt.
When you have like a word problem with A, you be like word direct.
A is, yes, that's exactly what it is. Now, I use A because I don't want you to get confused with slope. Some books will use K for the constant of proportionality instead of A, but it's the same thing, it's just a different letter. Just like, remember how you last year used N for slope, and now we use A for slope? Same idea. All right. Now, let's go back to our problem. It says, what is the person's paycheck after 17 hours? Okay, so you know what? I'm just going to plug in a 17 for W.
And 96 for P.
Okay, and then you're saying a 96 for P. If I know, the question is, what is the person's paycheck? So I don't know P. I want to take the 17 hours and plug it in right here to see what I'll get. But can I get P? 17 times A. What's A?
97.
We don't know A.
But couldn't you put 96?
96 represents what, Enrique?
What picture?
So that goes in for P. And then what were...
8
Well, that's
hours.
fine.
So isn't it like
Guys, focus. Marcus, enough. Here. Thank you, Enrique. You're on the right track. 96 is the paycheck. Thus, 96 will be the P value. If I want to find the A value, I need to plug in a W also. This 17 hours is one scenario right here. The next part is a whole other scenario. So I have the 17 hours, relax, for the first scenario, and I have $96 and 8 hours for the second scenario.
okay?
Which one of these can I use to find A? Why the bottom one, Claudia?
It gives you P and W.
Very good. Again, if I use the 17 by itself, I can't figure out A or P, because I don't know either of them. But if I use 96 and 8 together, if I put a 96 here, and I put an 8 over here, I can figure out A, just like the last problem. So you need to use the scenario that gives you enough information. The second scenario tells you that it is $96 after 8 hours. Based on that, I can find A, or the hourly rate. Okay, Jordan, yeah.
So, you can just do like a simple proportion.
Could you do a portion? Yes, you could. Absolutely. Now, the minute we go to indirect, it's not going to work the same way. So I'm trying to teach it this way, so it's going to work all the time. Okay? But yes, you could. So we divide by 8. What do you get for A, guys? 12. Now, that tells me actually that the person is making $12 an hour. Okay? Now, go back and think for a second. This is my general equation. Now that I know A, what do I do with it?
U times A times 17.
Very good, but before I even do that, let me just write down my specific equation, because then I'm going to plug into it. This is my specific because it is specific to this scenario. This is the general equation for direct variation. This is specific to this problem. Now, at this point in time, we worked 17 hours here. So, go ahead and plug in your 17 for W. What do you get from 12 times 17 here? Okay, so the person makes $204. Let's think now for another second. Is that double 96 or at least double 96? It is. Double 96 would give us 192. So this is clearly at least double 96. So our answer is reasonable. Because again, the first scenario, we worked 8 hours. The second scenario, we worked 17 hours. That's at least double. Since it's double, the number's got to be double the original 96. Exactly. That's the whole scenario. That's the whole point. Process. I'm trying to use math now with you guys as much as I can, so you're used to it. So don't even worry about it. All right. Let's look for a second at the next thing now.
Which was next? Direct.
I want to do an example of this is still direct, guys. We'll do indirect tomorrow. I want to do another example of direct with a table.
Indirect tomorrow?
Okay, yeah, we'll do indirect tomorrow. We'll spend 2 days on this. Give yourself 6 rows, label X and label Y, please. Now, again, just please write down the table with your numbers. What we're going to try and do here is determine the equation that represents the direct variation that's going on in this table. Okay, we're going to try and determine what the equation should be that represents direct variation. Look at the table for a second. Tell me something you notice about anything at all on here. Ebony. Why? Okay, she notices that if you multiply the x value in the first row, which is 2, by 3, she gets the 6. Very good. Claudia?
From the x to the y,
It increases, absolutely. It goes up, very good. If it went down, we'd be multiplying by a fraction. So very good point. Jordan? Very good. The 14 times 3 is also 42. Good job. Notice that. So what are we noticing? Everything should go, by a factor of it. A factor of 3. So again, right away we notice this is times 3, this is times 3. So what does that 3 represent?
A.
The A. Awesome, Marcus. Very good. The 3 is representing the A here. How can we figure that out? Let's go back to our direct variation equation. This is direct variation right here. Now, the problem we had earlier, we solved for A. If you solve this for A, divide by x on both sides. See how you get A equals y over x? This was from the very beginning of the notes in the first example. We said that A equals y over x. Take the y value divided by x for everything, guys. Take this 6 and divide it by this 2. What do you get? You get a 3. Take the 42, divide by 14, you still get 3. So what happens is this. If you are able to notice that more than one data point follows direct variation with the same a value, we can assume that it is in direct variation with an a value of 3. Again, if you notice that two of these sets of data points, this being the first set up here, this being the second set down here, if you notice that y over x is the same number, then you can state that the direct variation constant is that number. So here, we were able to see that 6 over 2 is 3. We're able to see that 42 over 14 is also 3. Thus, a is 3. So the equation that we are now have governing this entire table is y equals 3x. So that equation works for everything in this table now. So look at your other points now, because I don't have anything else. I want to find out this y. What should it be? 30. How do you know that, Melody? Very good. She put the 30 in here for x, or the 10 in here for x. 10 times 3 gives her the 30. What is the other one? Negative 3. And some of you are noticing already. If you want to go backwards, instead of multiplying by 3, what can you do? Divide by 3. Again, watch. Going this way, from left. Going from left. I can't do it on here. Okay. Let's try this way. Going from the left column to the right column, we clearly multiplied by 3. So if we go from the right column back to the left column over here, we can think of it as dividing by 3. So if I know this is C, what will this value here be?
Negative
3C.
What is it, Owen?
3C.
Why?
Because C
What do you have to do?
times that 3.
We said if you're moving from right to left, you multiply by 3. So if this is some value C, or some number C, this is triple whatever C is. We don't know what C is. C could be 5, and then the other number would be 15. Okay? The last one is the trickiest one. K over 3. Let's go through that one. We said, again, to go in this direction, you multiply by 3, right? So to go back in this direction, you divide by 3. Therefore, it's K over 3 here. You take whatever the y value is and divide it by 3. Now, this table was given to you as direct variation. Once we get through inverse variation, I will give you a table, and your goal will be to determine, is it direct or is it inverse? Okay, that's going to be your major goal. For now, though, this was given as direct. Let me give you your homework worksheet so you can take a look at it so there's no questions. For tonight, all I want you to do is number 1. Okay? Again, please write this down. Only do number 1. If you try 2 and 3, you can try them, but we didn't learn inverse yet. So they might be a little bit tricky. You're welcome to go ahead and look at the notes. The notes are already online. You can go ahead and take a look and see if you want to go ahead and do the homework. I always encourage that.
Okay.
But it was a nice.